In this screencast, I'm going to solve some inequalities, which you'll probably be seeing on quiz 4-5 tomorrow. So let's go to it. Alright, here we have an in-between inequality. So to solve an in-between inequality, I need to isolate the variable in the middle. So that means I'm going to have to subtract 1 from all three sides. That gives me that. And then I need to divide everything by -6. And when I do that, I'm dividing by a negative number, so I'm going to have to reverse the direction of the inequality signs. And I get x is in between 5 and -5. Let's see, it's including 5, but it's not including -5. And that's it. Okay, number 2 is a compound 4 inequality. So I really solve these as if I'm just solving two inequalities independently of each other. So let me look at the first one. I'm going to have to subtract 1. It's going to give me -35 there, -7x there. Then I'm going to divide by -7. And then that gives me x greater than or equal to 5. Okay, 1/2 is done. Now I'm going to subtract 10. That gives me 4. So I get 2x less than 4. Divide by 2. I've got a few mosquitoes here. And I get x less than 2. So that means x is greater than or equal to 5 or less than 2. So that's greater than or equal to 5. And that's less than 2. Let me draw brackets around that. Like that one. Alright, now I have an absolute value equation to solve an absolute value equation, which I always do by isolating the absolute value term on the left. So in this one it means I need to first move the 7 over. Then I'm going to divide by 9. And now that's going to give me 8 plus 3a equals 11. Alright, now that I have the absolute value expression isolated, I write two new equations. And one of them is going to look like that, and the other one is going to look like pretty much like the original. Then I just need to solve each of them. So subtract 8 gives me 3a equals -19. Divide by 3. That gives me a equals -19 over 3. And in the other one, subtract 8 gives me 3a equals 3. And then divide by 3. So that gives me a equals 1. So those are my two solutions. A equals -19/3 or a equals 1. Okay, and then finally I have an absolute value less than inequality and an absolute value greater than or equal to inequality. Alright, in the less than inequality, we're always going to convert that into an in-between inequality, and that allows us to get rid of the absolute value symbols. But before we do that, we have to isolate the absolute value expression on the left side of the equal sign. So to do that, I'm going to have to divide by 9. Okay, so now I'm ready to get rid of the absolute value symbols and convert into an in-between inequality. So what I do is I tack on another less than symbol out front, put 63 but change its sign, and then I can get rid of the absolute value symbols. And then I just need to solve. So I'm going to subtract 7 from all three sides. Oops, I see what I did. Forgot that 63 divided by 9 is 7, not 63. Okay, much better. And it also means this is actually negative 7 as well. Much better, hopefully. Okay. So this gives me negative 14 in between x and 0. And that's my solution. And I just need to graph it. So, let's see, I have less than symbols, so negative 14, 0, and connect them with a line segment. Okay, and finally I have a greater than or equal to absolute value inequality. These you always solve by converting into an OR compound inequality. But before I do that, I have to isolate the absolute value expression on the left side of the equation. So let me divide by 9. Alright, so now I'm ready to write my two new inequalities. So one of them is going to be negative 10k minus 3 less than or equal to negative 3. And the other one is going to be negative 10k minus 3 greater than or equal to 3. It looks very similar to the first one. So now let me solve each of those. So this one becomes negative 10k less than or equal to 0. Divide by negative 10. And I get k greater than or equal to 0, because I have to reverse the sign. And then the other one, I'm going to add 3 to both sides, and I get negative 10k greater than or equal to 6, and divide by negative 10, and I get, that gives me k less than or equal to negative 3/5, which is negative 0.6. So that's my solution set, and now I just need to graph. So I'm going to do greater than or equal to 0, or less than or equal to negative 3/5. Just going to look something like that. Let me just double check to make sure I got that right. Yep, I did. Alright, I hope you found this screencast helpful. And you'll tune in for more in the future. I'm sure I'll be making lots of these this school year. So, hope to see you again.